Hello and welcome everyone. This is Noah, and in this video we're going to look at domain changes to when we're adding or subtracting rational functions. All right, let's take a look at these examples. We want to add or subtract the following rational expressions together as indicated. Make notes of domain changes that occur at each step, and then we'll state the difference between the domain of the original expression and that of the final expression. All right, so we're going to start with 2x squared plus 7 over x plus 3, and we're going to add to that 6x minus 7 over x plus 3. We're starting here with a problem that already has a common denominator, so we don't need to worry about that. We just need to add the terms together on top. So we're going to have 2x squared on top. The plus 7 and minus 7 are going to cancel, but we will still have a plus 6x up there. On the bottom, we keep our common denominator of x plus 3. All right, continuing with our simplification, we want to factor the top next. The bottom's not going to factor. We can pull a 2x out of the top, and we'll be left with an x plus 3 over x plus 3. And then we can cancel the x plus 3's top and bottom, leaving us with just the 2x. So we need now this is a review of us just adding these together, but let's now look at the domain changes. How did the domain change and where did it change? So the domain at the very beginning was simply the set of x such that x cannot equal negative 3. And since we just have that single denominator, it's repeated, but that x plus 3 for the denominators means that x cannot equal negative 3. And that doesn't change in the next step. Domain's the same. And then in the next step, it's again the same. It's not until after we cancel where the domain at the bottom is now all the real numbers, negative infinity to infinity. So what we want to say is that these three are equal. These are equal everywhere except when x is negative 3. If x is negative 3, the first three expressions are undefined, while that final one, 2x, we could plug in that negative 3 and get an output for it. So this is kind of repeating what we've done in the previous videos. We're just reviewing the addition and kind of repeating this idea of how to note the domain changes. We're given x squared plus 2x minus 2. Oops, excuse me. Let's start that over again. That screen got all jittery on me. We have x squared plus 2x minus 2 over x squared plus 3x minus 10. Then we add to that 5x plus 12 over x squared plus 3x minus 10. The denominators are once again the same here, so I don't need to worry about a common denominator. That's nice. The numerators will add together. We have an x squared, and then our x terms, we've got a 2x plus 5x is a 7x. And we've got minus 2 plus 12 is a plus 10. The bottom will just leave that same denominator, x squared plus 3x minus 10. We'll continue forward with this by factoring the top. The x squared plus 7x plus 10 can factor as x in the first position, x in the second position. We want to get two numbers that multiply to be 10 and add to be 7. So our option here is a 2 and a 5 will add up to 7. The denominator is x squared plus 3x minus 10, and we want to factor this with an x in the first positions. And now we want a negative 10 to factor in such a way that they add up to positive 3. So 1 and 10 is not going to get us 3, it'll get us 11 or 9, depending on how we look at it. And then if I have 2 and 5, I can do a positive 5 and a negative 2 will add up to a positive 3 and multiply to a negative 10. So we'll do that, minus 2 and plus 5. So we can see now that we can cancel the x plus 5's. Those go away, and we're left with x plus 2 over x minus 2 on the bottom. So if we take a look at the domains here, move these over to the other side so I can stuff over here. There we go. The domain for the first three is going to be the set of x such that x cannot equal 2 or negative 5. We're just seeing that from that line where we've already factored that denominator. And then the domain on the last line is the set of x such that x cannot equal 2, right? The only denominator here is x minus 2. The x plus 5 in the denominator is no longer there, so we no longer have that domain restriction, which means that the first three expressions are equal. I'll write this out fully. These are equal so long as x doesn't equal negative 5, right? If x does equal negative 5, they are no longer equal. Note that I've got two different wordings here. Both are fine. In the first problem, I said these are equal everywhere except when x equals negative 3. And in this problem that we just did, I'm saying these are equal so long as x does not equal negative 5. So just kind of change that wording a little bit, but they have the same meaning. So make sure you're reading those and understanding how they both work and have the same idea behind them. All right, let's keep on going here. We finally get to a problem. This is C. Software does not like doing the numbering the way that I do. Part C here, we have 6 over x squared minus 6x minus x over 6x minus 36. So I'm going to look at the first fraction, 6 over x squared minus 6x, and I'm going to factor the denominator. I'm just going to pull an x out. X squared minus 6x. I'm going to pull an x out and be left with x times x minus 6. For the second fraction, x over 6x minus 36, we can look at that denominator and note that we could factor out a 6, leaving us with 6 times, in parentheses, x minus 6. So this is kind of nice. The x minus 6 is already in both, but I'm going to need to multiply the first fraction, top and bottom, by 6, and the second fraction I need to multiply top and bottom by x to get our common denominator, which I'm going to write on this next line now, 6x times x minus 6 in that denominator. So that's going to be the same on both of these, 6x times x minus 6. Now the top of the first fraction becomes a 36 when we multiply the 6 by the 6, and the top of the second fraction is going to be an x squared. Cool, so now we've got our common denominator, and we can bring these together as 36 minus x squared over 6x times x minus 6. And so far we haven't canceled anything, right? We haven't changed our domain in any way because we haven't canceled anything. Let me give myself a little more room here. But now I want to factor the numerator of this. And when I do that, I get 6 minus x times 6 plus x over 6x times x minus 6. Now, we've gone over something like this before. I think I want to take a little bit more time in this lesson to really emphasize what I'm about to do here. I'm going to do this really quickly, and then I'll show how I can do it, why it's justified, and then this will hopefully speed things up for you in the future. I want to key in on the 6 minus x versus the x minus 6. They're the same thing, but they're the opposite order. To highlight how these are different, so I'm going to look at 2 minus 7 versus 7 minus 2. 2 minus 7 gives us negative 5. 7 minus 2 is a positive 5. So if we flip subtraction, we get the same number, but with opposite signs. One will be positive and one will be negative. So what I'm going to do is I'm going to flip this subtraction, the on top, the 6 minus x, I'm going to go and make that an x minus 6. But I need to put a negative in front of it. To do so, I'm going to justify this another way in a second as well. So if we look at this 2 minus 7 versus 7 minus 2, the 7 minus 2 is equal to the opposite, the negative of 2 minus 7, right? If I did that in steps, it would be negative. Negative 5 would still give us a positive 5, right? If I flip the order and then negate, we'll still get the same answer, because flipping the order negates it once. So I put another negative, and that negates it again. To highlight, so that's how we can do this really quickly, is just flip and negate. So we can flip the subtraction. And negate. And we can do that every time. It'll always work. To also see how this is justified, if I took that negative and multiplied it back in, that's really a negative 1. That would give us a negative x, and then a plus 6, which is the same as what we have above. We have a positive 6 and a minus x. So we can see that it does, in fact, work that way as well. Okay, enough on that. Let's go ahead and finish this problem out. We can cancel the x minus 6's now, and we'll have a minus 6 plus x on top over 6x on the bottom. Move some of this stuff over to the other side for us. That's fine. And now let's look at our domain. So the domain is the same. The domain is going to be the set of x such that x cannot equal 0 or 6. And I'm seeing that from the second line where we've already factored things. And then that doesn't change all the way through until we cancel. Then at the last step, the domain does change since we canceled the x minus 6. And we'll get the domain equals the set of x such that x cannot equal 0 only. The restriction of x not being able to be 6 before is no longer there. So we can say that these are equal unless, I didn't think it was going to take that much space to get through this. That's okay. Unless x equals 6, in which case they're different if x is 6, right? Undefined in the original and the following lines, and then at the last one, we could plug that in. All right, let's do one more to close out this video. For this next part, we have x over 2x squared minus 5x minus 7 minus 2 over 2x minus x minus 21. So here we need to factor the denominators to figure out how to get a common denominator. So the first denominator on the left, 2x squared minus 5x minus 7. We need a 2x squared, so one of them has to be a 2x and the second has to be an x. The x on top can stay, and then the other two numbers need to be a 7. So I could try a 7 and a 1 here. This would give us a 2x and a 7x. And that looks like we could get those to add to negative 5. We want a minus 7x and a plus 2x to give us 5x there. To give us a minus 5x specifically. Cool. And then we'll go minus our second fraction. We've got the 2 on top. The denominator, 2x squared minus x minus 21. We want to factor. Once again, for the 2x squared, we need a 2x and then an x in the first positions. Then we want a 21 in the second positions. So we could try 3 and 4. And this will give us an 8x and a 3x. And those are not going to add to -1 in any way. So we'll try again. Maybe I'll just swap them to see what happens. We can have a 6x and a 4x. It's closer, but still not... Wait, 4 times 3 doesn't work. What am I... I just went dyslexic. I was thinking 12, not 21. All right, so if you were confused there for a second, you were correct, and I'm very sorry about that. Let's just make our adjustment here. For 21, we'd need like a 3 and a 7. So we'd have a 14x and a 3x. And that's not going to work, so let's try swapping those. Put a 7 in the first one and a 3 in the second one. This will give us a, there we go, 6. Oh, I hate it when the software glitches. Okay, we'll have a 6x and then the 7x from the middle terms. So we want a minus 7x and a positive 6x, so we'll make a minus 7 and a plus 3 there. Cool, now we can see what we need to get a common denominator. Let's write that common denominator first. This is going to be over 2x minus 7 is already common to both, so we don't need to worry about that. We need an x plus 1, and we also need an x plus 3. So I'll write that for both fractions. The second fraction, same thing, 2x minus 7, x plus 1, and x plus 3. So I'm going to multiply the first fraction. I need to multiply by x plus 3, top and bottom. And in the second fraction, we need to tack on an x plus 1, top and bottom, to get our common denominator. So in the numerator of the first one, we had an x. We're multiplying that by x plus 3, so that will give us an x squared plus 3x after distributing. There we go. And then on our second one, we had a 2 on top, so we'll multiply that by the x plus 1 to get 2x plus 2. All right, moving right along here. Going to take that first fraction and the second fraction. We want to add them together now, or rather subtract them. So the denominator, I'll copy down 2x minus 7 times x plus 1 times x plus 3. And then on top, we have an x squared. And I've got a 3x minus 2x, right? If I'm looking at that, 3x minus 2x is a positive x. And then this minus distributes to that 2 as well, so we'll have a minus 2 there. We're subtracting that numerator completely. Cool. So I still haven't canceled anything, still no domain changes. We need to factor this numerator now. We have x squared plus x minus 2. So we want an x in the first positions, and then I need a 1 and a 2 in the second positions. Make that a plus 2 and a minus 1 to give us a positive x in the middle. On the denominator, we have 2x minus 7 times x plus 1 times x plus 3. And look at this, there's nothing cancels. So the domain for all of them, it doesn't change. The domain is always, for this problem at least, the set of x such that x cannot equal, the 2x minus 7 cannot equal 0. So add the 7 and divide by 2, x cannot equal 7 halves. And then we also, it cannot equal -1 or -3 from the other two that we see here. And so these are always equal. All of these are always equal. Cool, so no domain changes in that one. And that can happen, right? We want to note that that's also a possibility. So cool. There we go. I hope that's some good review of these and gives you some idea, some better idea. Improving on notate that how we. That's it for this video. Go ahead and give the Now You Try problems a shot, and in the next one we will run through those solutions. Thanks much for watching. See you soon.